Ladies and gentlemen, here we go. Welcome at Hannover Messe, also in our live stream. Ladies and gentlemen, welcome. Now we want to talk about sustainable production, use and recycling of batteries. The Battery Pass project aims to develop and demonstrate a digital battery passport. And we are honored to welcome the Parliamentary State Secretary at the Minister for Economic Affairs and Climate Action for the symbolic handover of the results documents. Welcome, Stefan Wenzel.
Thank you very much, Mrs. van Veen. Ladies and gentlemen, dear Battery Pass Consortium, a warm welcome from my part on the stage of the Federal Ministry of Economic Affairs and Climate Action on this year's Hannover Fair, or in German Hannover Messe, the world's largest industrial trade show for capital goods. I'm very happy to welcome on stage an illustrious group from companies, research and think tanks, the Battery Pass Consortium, and Nomen et Omen, as you will see, to present to us their newest result on the battery passport. But let me start at the beginning. Batteries will become what fossil fuels have been for many decades, the essential form of energy storage in ever more applications. Battery-powered cars are commonplace right now. We wish to have 50 million up to 2030 in Germany. We're fighting for it. Other countries are faster. For example, Norway, our partner country this year at the Hannover Fair, is very good with battery-powered cars already. Trucks are being electrified more and more, as are tools, forklifts and even trains. Grid storage requires batteries as well. The battery industry is scaling rapidly worldwide. Batteries host vast potential for business and for decarbonization, but they come with challenges too. Most significantly, they require large amounts of energy and resources to produce them. More concretely, first, the CO2 reduction potential of electric cars crucially depends on the production condition of the batteries. We need to know what goes in there in order to monitor and benchmark the CO2 footprint of batteries. It is our goal to make electric cars in the greenest possible way. But even today, every electric car, if you look at the amount of energy they need to drive 100k, it's a 1.5 liter car, the equivalent, because you don't need more than 15 kilowatt hours for 100 Ks. And second, there can be a severe social impact of the raw materials production for batteries. What needs to be ruled out would example child labor or unsustainable conditions in cobalt production. We need transparency on the production conditions to curb negative impacts. And third, as the market grows so fast, we need to make sure quickly that all the batteries being put onto the market in the years to come are already fit for circularity, means they can be used in a second life application and easily recycled. These challenges, the environmental footprint, social responsibility, circularity, will be tackled in Europe with the EU battery regulation. And that puts stringent requirements on these aspects. But how? How do you show as a producer of batteries to the authorities and to your customers that your batteries comply with these requirements, that they are indeed sustainable and green? This is where the digital product passport comes into play. In this case, the battery passport. The EU battery regulation requires a battery passport for batteries in electric vehicles, stationary storage systems, and large industrial batteries. The Battery Pass project, funded by our ministry since 2022 with 8 million euros, aims to demonstrate a workable pilot of the battery passport that complies with the EU battery regulation. The work is done in a consortium of industry, academia, and think tanks joining forces to demonstrate that a digital battery pass can be realized in a workable way. It covers all necessary criteria to make sure that batteries are sustainable. The project builds on several other activities, partly also supported by our house, be in the Catena X network, the Circular Economy Initiative Germany, or the Global Battery Alliance. Last year, on this stage of the Ministry of Economy and Climate Action, the consortium has presented the first key results, being the fruit of intense work over the first year. This year, you are taking the next 3 steps at once. I'm impressed by all the pieces already in one place. First, you are presenting a study on the value of the battery passport. Second, you are giving a technical guidance for the implementation of the battery passport to prospective users. And third, you are introducing a software demonstrator of the battery passport live on stage to show how it can actually work and look like. And I'm looking forward to that. I thank you very much for the results so far. Please keep inspiring people and institutions to respond to the need for greater sustainability. Thank you very much for your work, and I'm happy to have you here now beside me. And I hand over to our moderator, Mrs. van Veen.
Thank you so much, Stefan Wenzel, for this introduction and these warm words. And you call them joint forces. We want to call them on stage now to hear about the newest results. Please welcome Tilman Wahle. He's Director for Sustainable Mobility and Batteries at Systemic. Professor Thomas Knote, he's Head of Business Process and Factory Management at Fraunhofer IPK. And Nikolai D'Agostino, he's Program Director of Circular. Welcome, gentlemen.
So, thank you, State Secretary Wenzel, for the warm words and the warm welcome. We're really honored to have the opportunity to launch 3 of the next deliverables that we've been working on as a battery consortium, a battery pass consortium over the last year in this very important project, which for us is a high priority project, not to speak of one of our passion projects. Battery Pass, as you alluded to, State Secretary Wenzel, is a consortium of 11 rather leading organizations, including leading German automotive companies, battery cell manufacturers, battery recyclers, and cathode active material producers, and co-led together here the work packages. We have Fraunhofer and Circular that led the delivery of 2 of these work packages, and from our end, Systemic Change-Making Sustainability Advisory that co-created this program. We've been very honored to have been supported financially by the ministry, but also beyond that strategically, and have been able to drive this project. It's in total a 3-year project. We're 2/3 through, and so today we're very happy to have the next milestones achieved. Last year, we released the first content guidance on battery passports according to the EU regulation. They will be required by 2027. And we looked into this in depth. What will companies have to do, interpreting the law and filling the gaps via the content guidance to make sure that it is actually implementable and industry friendly. Today, we're launching, and are looking forward to handing this over to the State Secretary, the technical guidance and the standard stack, which is already starting to inform the European standardization processes, a technical demonstrator, software demonstrator that puts this all into practice and proves that it's viable, both in terms of the content and the technology, bring the software to life, and then the study to look into really what are the use cases specifically, how can companies use this, and therefore also how do we need to implement battery passports so that they become an industrial asset going far beyond compliance. So for the value assessment, we looked at the entire breadth of ESG criteria, economic benefits, social benefits, environmental impacts. How could the battery passport be applied along the value chain to support economic activities such as testing for reselling batteries, such as recycling, such as logistics, in order to overall improve sustainability and achieve better business results. Reached out to a broad stakeholder group, not only within the consortium, but far beyond into the European ecosystem, because this is really fundamentally directed at the European ecosystem, and ultimately developed this study, which is now available on our website. For the battery passport, this covers ultimately the entire life cycle. It will require information on manufacturing, on the performance, on the state of health, on sustainability parameters and circular economy relevant information across the entire life cycle, starting at the mine, going through the entire life, all the way down to recycling, and then back, of course, as part of a secondary material. And we looked into a large amount of potential use cases and identified 12 that are really high value and can be substantiated according to industry. And of these, we quantified 3. And so we're very happy to have built these analytics very robustly with industry, having challenged these with many relevant economic operators, from the cell manufacturers through the recyclers, refurbishers, repurposers, and the automotive industry, of course, as well. And we find that with applying the battery passport and with information that it will provide companies over the lifetime, we can actually see that recycling costs can be reduced and efficiency can be improved by the recyclers, as there's greater information on how to disassemble batteries and more efficiently put them into processes, optimize these for greater outcomes, greater recovery of high value materials, leading them in the loop. Also, during the lifetime already, technical testing today is often a chore with proprietary APIs and access to data. The battery passport will provide a lot of the data points required for analytical testing and therefore facilitate this, making this more affordable, more easy, faster, and thereby support greater resale and ultimately use of the batteries, hopefully extending their lifetimes. Up to 10% reduction in technical testing costs is what we found. And last but not least, by actually identifying where the batteries are and ensuring that they're handled well at their end of life, it actually could reduce the unforeseen leakage of batteries out of the system and therefore retain more batteries for recollection in our European economy. You can scan those QR codes, of course. It's an interactive, dynamic model online that you can use and play around with assumptions yourself to see about the value. So additional resources are on our website, and just as a little outlook, we have 1 more year to go, and now looking forward, today we're launching the technical guidance. Professor Knote will continue supporting the standardization process. Circular and our group will continue building the software product to actually put this into place, among other solutions, and ultimately, until next year, conclude our project. But going beyond that, we're also setting foundations for other digital product passports in the EU for other sectors, and I hope to work with all of you together to advance the digital product passport ecosystems overall in an interoperable and efficient way to make maximum use for the European economy. And of course, we're also here and available to support companies that are affected to put this into practice. What does it mean for them? What strategic options exist? And with that, I'm handing on to you, Thomas, for the next piece on the technical guidance. Thank you.
Thank you so much, Tilman. Now it's my turn to tell you the most boring stuff, means standardization and standards. But at the end, Tilman had explained how about the data, but how the data comes into the system so we can operate that. So this is just an idea of a battery passport, but we do have a lot of challenges on that. Yeah? Because maybe you know already there are a lot of passport systems in the world. The question is, they are singular, they are not interoperable. And here you can see such technologies just for the identification, which have to be bring in line. Yeah? That's the next one. So we, with the batteries, are not alone. The ESPR is mentioned for mostly all products we have in the world. So at least the battery pass is just a pilot for other digital product passports. So this means we have to create a system which is interoperable with other sectors, with other product groups. And last but not least, we are not alone in the world. Yeah? We have our European system, the ESPR, which is driven, for instance, by circularity. But in US, we have other objectives, the same as in Asia. But in total, we are living in global supply chains. How to bring this in line, and this is at least one of our objectives in this technical product passport system in order to bring this and to make it happen. So, and you can visit our booth in B24, where we explain to you how about the requirements, for instance, for companies. What does it mean to implement such a passport? So we remove the fog we have today. The next one, we created a, so to speak, technical standard stack, which at least align the different standards we have already in a way that they can become compatible to each other. With a system architecture, we can demonstrate that coexisting standards and technologies can work together in order to reduce cost for that. You know, a lot of companies, a lot of people are aware of regulation and all the costs about that. And here standardization can bring a solution. And last but not least, we have to help standardization, but as well companies to implement. For that, we created, for instance, an assessment system in order to see where we are and how to implement. And how this can be happen, because to some extent, some of you would mind, he's talking about something like go over the water. And my colleague, Nico D'Agostino, will demonstrate you that this can be happen, to have coexisting standards.
Okay, yeah, thank you, Thomas. Okay, so you put the bar very high, so I show you now how to walk over water. Let's see. So, yeah, first of all, what we did is actually to translate the data attribute list that we published last year at this place into a machine-readable model. And one of the main requirement that we had is to be as technology open as possible. So we don't want to select a single format, but we intended to define kind of an intermediate layer which defines a semantic model from which technology-specific data models can be derived. What we also did is to break down the about 100 data points that we had in the model into 7 different categories, and when you look at these categories are completely agnostic from the product and can also be reduced for other products. As mentioned before, the battery passport, we see it as a blueprint for the DPP. So what we then further did is to take the results from work package 3. We had a very close cooperation with IPK, with Professor Knote. You can see here a system architecture which is derived also from the requirements from the ESPR, the Eco Design Directive for Sustainable Products, which gives some clear recommendations how a DPP system should look like. And an important topic is that the data should not be all in a central database. So we set up a distributed architecture where we can see at the right side of the slide, you can see that we have different repositories and each data repository lives at each economic operator. So this is a responsible company who bring the battery passport in the market, and they can use their own technology. So here you can see we implemented the AAS, which we put together the data model together with the Catena X. We had another technology, NGS-ILD, and NoSQL. And we could show that even if we use different data formats, the data models are interoperable because of a common data model. What is also shown in the demonstrator is that we have a central registry. So in order to get access with a single QR code, you need a central registry, which is probably hosted by the European Commission, which has all the information which is needed to redirect the data from the economic operator to a battery pass viewer. And this is what we actually presented in the project. So here you can see we have At the left side, you see a screenshot from the software demonstrator, but we also created a physical demonstrator. So we think it was a good idea to build the complete battery value chain made with Lego bricks in order to explain and make the rather abstract concept of a DPP more tangible, and explain a little bit where is the data coming from in the battery passport, where is the data used in the battery passport, and we hope to give some insights. And then I brought you a small video which shows the actual demonstrator. Maybe we can start this. So this is the entry point. You can type in or scan for the QR code, then you get a battery ID, and this brings you to a kind of a landing page where you can see the most important information. So we have information about the carbon footprint. The EU regulation requires 4 different sections from the value chain. We can show the actual consumption of the battery. We see the recycled content share for the different raw materials, and then we can also go a little bit deeper into the details. So all the 100 data points are actually covered in the 7 content clusters. We have the material composition, we have the performance information, which we also linked to the Lego demonstrator. We have compliance information. These are mainly links to documents. Supply chain was mentioned by the State Secretary, which is important to make sure. And we have circularity information to give information about the way how the battery is actually rebuilt. And with this, I would like to close my presentation. I would like to invite you to our booth. It's B24, the Fraunhofer booth, and there we can show you a little bit more deeper detail what we did, and I hope you can come. And I'm pleased to have good discussions with you. And then I think I would hand over now to the handover ceremony.
Thank you. I have my own microphone that I will use. Congratulations, gentlemen, to these newest results and for all these valuable insights. So there's more to come. Next year, Hannover Messe, we're going to have you on stage again to see the final results. Thank you so much. I know that we would like to take a picture right now because this is a very special moment. I would like to ask Stefan Wenzel back on stage for that picture, as well as Dr. Johannes Simberg, Luise Müller-Hofstede, and Dr. Niklas Niemann. Und Professor Holger Kohl, wird mir noch geflüstert. Da ist er doch. Und ich glaube, wir müssen mal von den Tischen weggehen, sonst kriegen wir kein schönes Foto. Wir rücken einfach mal ein Stückchen weiter rüber. Noch einmal in die Mitte. Nein, bitte. So, wer ist denn Head of Photo? Who's the one we all have to look at? There she is.